Ken, please, are you recording?
I just remembered and just clicked on the record button.
Okay.
So let's look at
And please, if anybody has any question, just lift your hand so that we ask you. Okay.
Sure. So just with the examples we started with, so for instance, we had a variable called school. This is a container, and we had in there something like University of Ghana. Then, based on the working definition we have on line 4, we are saying that whatever data we have over here, if it is declared in a single quotation mark or in a double quotation mark, it is a string. Clearly, you could see that everything we have in terms of the string or in terms of that collection of characters, as we have with the University of Ghana, everything is in a single quotation mark. If I'm to take off this quotation mark, clearly I get a warning that there's a potential problem somewhere around. So Python expects us to put things in this quotation mark this way. Now I don't have any problem. And we saw using the print function where you could print that value in that container. So clearly when I run this piece of logic, we get University of Ghana printed out over here. But here is a big question. We want to verify that indeed this is a string. So what we are going to do is we are going to use, so far the only vocabulary, like I did indicate, that we've learned is this print function. And it is giving us the functionality or the utility of printing things into the terminal. And that's exactly what we see over here. Now, we also want to learn new things, okay? So over here, we want to check the data type of this variable. We want to verify and check that data type. So if you want to check the data type, then there is something we call a class, okay? So this is actually a class, which we call the type. So when I do type and then pass in school, on line 7, the logic I'm trying to implement over here is, well, I want to do something with school. And we know that school is storing whatever sequence or collection of characters we have over here. But yes, I want to check something on school. And then what I want to check is the data type of school. And that's why I'm using the type class over here. So in order to see this in the terminal, I then have to wrap everything up as I have it this way in the print function. So on line 6, indeed, school is going to be printed out, which is the University of Ghana as we have it. Then on line 7, something around school is going to print out, but because we are passing it in the type class, it is actually going to check the type of the data being stored in the variable school and it's going to print it out for us. So having said that, I'm going to run this, and that's exactly what we have over here. So clearly we see that on line 6, we are getting University of Ghana. Then on line 7, we are getting this class str. So let's just focus on the str for now. And this str is what Python will refer to as a string. So now let's look at another example. And with this example, I'm going to say department. And I'm going to be a little bit biased over here and use computer engineering department. And this time around, I'm going to put it in a double quotation mark. So I'm going to say computer engineering. So clearly, apart from the fact that school and departments are different variable names, okay, a distinction in terms of what we see just to the eyes is the fact that the variable or the data school, which is the University of Ghana, is declared in a single quotation mark. And then what we have with computer engineering is declared in a double quotation mark. All that we want to prove is, we want to check if indeed this is also a string. So over here, I'm going to print the department variable over here. And I'm also going to change school to department and see what I get. So when I run this, indeed, from line 7, I'm getting computer engineering showing up over here. And I'm also getting str, which is showing that this is a string. Now, the key takeaway is, and that's what we have from line 4, is the fact that, well, it is a string, regardless of the fact that it is declared in a single or double quotation mark. The most important thing is there should be a quotation mark, and either a single or double, it is a string. And like I did indicate, there are instances where we will need a double quotation mark and there are instances where we need a single quotation mark. As and when it becomes necessary, we are going to cover that later on. So let me just comment these ones out so that they don't get executed the next time I write any code. Now, the next data type we are going to look at is the int. And the int is the integer. And the working definition of what an integer is, right from algebra to what we know now, hasn't changed. So an integer is a positive or negative whole number. So all the positive or negative whole numbers that you know, they are all integers. And we can actually check with this simple example. So I'm declaring a variable age, and I'll save this 12 over here. So the moment I do age is equal to 12, clearly this is a whole number. And for which reason we are saying that this variable age is of a data type integer. So we can actually verify that indeed I'm going to print out age over here, and I'm also going to print out the data type of age. So I'll quickly do this and put everything in a print function inside of, how do you call it? Inside of the type class. And then when I run this, currently we could see that yes, we are getting 12 over here, which is actually what we are printing from line 12. And we're also getting int because this is an integer. It is a whole number as we have it over here. Now, assuming it was a negative, which of course we can't get a negative age, okay, but then we just want to test whether positive or negative, it is an integer. So when I do it this way and I run it, we still get a negative 12 over here, and we are still maintaining the fact that this is an integer. It is either a positive or negative whole number. Now let me revert back to 12. And now let me just show you something quite interesting. So I'm going to declare a variable which is going to be capital letter H. Remember earlier on last Friday, we learned that Python is case sensitive, okay? So what I'm going to do is I'm going to declare a variable and I'm going to put 90 over here. So let me do a printing of that capital letter H. Now, I just want to show you this, and this is actually for the optics, okay? We want to see how it looks, but then see something. When I run this, what I have first printing out, that is what we are getting from line 13. We are printing small letter H, which is this 12 over here. And then on line 15, I'm printing capital letter H, which is this 13, this 90 over here. Now, in order to even make things look a little bit confusing, if I have small letter h as 12 this way, and I have capital letter H as also another 12 this way, when I run it, we get both of them showing the same thing. I mean, for the optics, they look the same. All right. But then in terms of data types, they are completely two different things altogether, and Python is going to treat them differently. So see what I'm going to do. I'm actually going to, for instance, print the data type of small letter h, and also print the data type of capital letter H. So we just want to verify some few things over here. They look the same, but then are they really the same? And whether they are the same or not is going to be verified by their data types. So when I run this, of course, we get 12 over here. And the first one we get, which is small letter h, is of a type int. But then the second one we have, which is also showing us almost the same as the 12 in terms of how it looks, okay? But then this one is telling us that this is a string. And what we have, capital letter H, it is a string because if you have to go back to that working definition that we have of a string, we are saying that it is a collection of characters. Remember what I said earlier on, if this was a PowerPoint presentation, I would have highlighted this in red, just for emphasis, to say that, well, those characters we are collecting, it could be A, B, C, D, it could be 1, 2, 3, or whatever thing. The moment it is declared in a single or double quotation mark, it makes it a string. That's basically that. And when we leave it open like this, like we have a small letter h, then this one becomes an integer. All right. So let me just comment these ones out and let's move on to the next one. And the next one we have over here is a float. So a float is a fractional or decimal value. And one of the examples I use very often in class is some kind of a float that you are all familiar with, which is your GPA. Okay. So let's say we have a student here whose GPA is 3.99. All right. Now, this 3.99 is a fractional value or a decimal value. So whenever I do something dot something, Python will automatically know that, okay, even though this is a number, but then it is not a whole number. It is a fraction or a decimal value. So I'm going to look at this as a float. So now if I'm once again to print the variable GPA and also print out the data type of GPA. If I run this, we get to see that, yes, we are getting 3.99 over here. And we are getting to actually verify that this is a float or a floating point value. So that's just by way of knowing the differences between the integer. The integer is a positive or negative whole number. The float is, let me actually do this. The float is this. But then the point is, even if it is a negative number like this, okay, so negative 3.99, it is still a float because it is of a decimal value. It is of a fraction. So we are still getting a float over here. So that's just by way of emphasis. So now let's move on to the next one, which there are few programming languages that support complex numbers, okay? And I believe in the minds of those who are writing Python, we're like, okay, there's probably going to be a lot of computation going on over there. So let's create a data type that supports complex numbers. And I think maybe apart from those in level 100, which I may excuse them a little bit if they don't know what complex numbers are. I believe continuous students, because of the algebra and calculus that probably have, you know what these complex numbers are. But then for the uninitiated, the complex numbers, there's a number which consists of basically two parts. Okay, so it has a real part and an imaginary part. It looks very crazy, but then if I'm to, for instance, ask you to calculate, for instance, the square root of of 9, and if it is an elective math question, then the answer is a plus or minus 3, because 9 is a perfect square, so you get a plus or minus 3. So normally, the opposite, okay, or the complement of square root is square. So the answer you get from a square root, if you square it, you should get back the number. So if you square a positive 3, you are going to get your 9 back. And if you square a negative 3, you are also going to get your 9 back. However, if we have, let's say, the square root of negative 9, then before the introduction of complex numbers, my understanding was it is not possible, because we cannot take the square root of a negative number. But then mathematically, and of course, with engineers, we doing advanced mathematics, we get to understand that we can still find the roots of negative numbers, and that will result a complex number, because what that gives us is going to give us a real part. It's going to give us two things. Part of the number is going to be a real number, and we're also going to have the imaginary parts. And I believe we've all seen this, or most of us have seen this. So let me show you a typical example. I can have x is equal to, now for a typical complex number, okay, the how do you call it? For a typical complex number, like I said, we are going to have a real part and an imaginary part. Now the real part is basically going to be any real number, and the imaginary part is going to be any imaginary part, so to speak. But then you'll probably see a typical example, like let's say 4 plus I, or maybe 4 plus 2i. And now this 4 is going to be the real part, and the plus 2i is going to be the imaginary part. So normally you either see I, or sometimes you see something like, let's say 3 minus 5j. So these ones, the real parts don't really change, but then it is the imaginary part that you either see either an I or a J. But it pretty much depends on the book you are reading. If you are reading electrical books, you are definitely going to see the J, because I in most of these books represent current. So in order not to bring confusion, we replace it with a J. And that's exactly what Python also does. So let me give a typical example that I just used. So if I have 4 plus 2i, now when I do 2i is not going to work. Clearly, I get to see that there's a problem. So Python only accepts the J version, okay? So when I do 4 plus 2j, Python will understand that this is a complex number. And for which reason, if I'm to once again check X, okay, or try to print X and also print the data type of X. And let me just clear the terminal so that if I run this, we get to see that indeed we get the 4 plus 2j, and then we get to see that this is of a data type complex. In that same way, if I'm to do, for instance, let's say 3 minus 5j or 5i, and then if I'm to run this, we get to see that this is of a complex number or a complex data type. So these are the various data types that we have. And the whole calculation, let's say the addition and subtraction and multiplication of complex numbers are a little bit different from the usual ones that we know. But then they are not too difficult. And since that's not the main focus we have over here, I'm not going to go so much into that. So let's move on to Boolean data types. And a Boolean data type represents data that can exist in only 2 forms. So once again, we've done basic electronics, we've done some Boolean algebra, some logic gates and stuff like that. That's the inspiration over here. So a typical example is we can have, let's say, students who are in the School of Engineering, and out of that number, we have students who are part of this program, okay, this Google Machine Learning program. So to be part of this program, it is either you are in or not. You cannot have an in-between status, okay? So let's say the question I want to say is, did the person register? So it's registered. And over here, I can either say true. So when I say true, and we are going to come back to this true, so please pay attention. If I'm to print, this is registered variable as I have over here, and also try and check out the data type of this variable, I get to see that, yes, indeed, we are getting a true over here, and we are seeing a bool, which is a Boolean data type. So like I said, it is either you registered for it or you did not. There's nothing like, no, I can't think of it. So it is either true or it is either false, as we have it this way. And there's no in between. So yes, if it is false, then it is still a Boolean data type. Now, one of the things I should mention is that, look at what I have over here. The moment I type in false, you see that there's some kind of a highlight of a color, some few things, okay, which is very glaring. You get to see that this we see is different from we putting this in some quotation mark. If I put it in a quotation mark, whether single or double, then this becomes a string. Okay, when I run this now, this is the same false, but then this is a string. But then if I want the Boolean data type false, I just have to put it this way. And this is one of the things we saw earlier on when we were discussing the reserved keywords. Okay, so for instance, remember what I said, this false is one of those reserved keywords, just as true. So Python has reserved, for instance, true or false, so that you don't use them in your variable names, but then you are going to use them later on to represent Boolean data, whether true or false, on or off, high or low. Good. And that's the reason why we cannot use these ones to, for instance, for our variable names, because if we are going to say true, as I have it this way, is equal to something, clearly Python becomes confused. It says that no, I don't understand what you are trying to use over here, because I've reserved this so that I can know that whenever you use it, you want to actually represent a Boolean data type. And that's why we cannot use this for our variable names. But however, like I did indicate and stress on, we are still going to use them, but then not for our variable names. And also pay attention that when I do a capital letter through this way, I get a problem. And this one, I'm going to ask a question. So why do you think small letter true is not working, but then capital letter true seems to be working over here? Anybody can raise his or her hand and give it a try. Okay, Daniel.
Okay, so it's due to the first letter. It's not capitalized, so it's not considered as a reserved keyword.
Okay. That's, I mean, an obvious change I did. Okay. And I think Irama has, yes, exactly. So Irama also has it in the chat over here that because Python is case sensitive. So yes, that's true. It is because of the case sensitivity. So this capital letter true is different from small letter true, and it is always going to be different from that because of the case sensitivity of Python. So yes, in as much as we want to represent a Boolean data type, we have to represent it the way it is supposed to be represented, and that is we using the capital letter true and the small letter true. So that brings us to the end of the various data and data types. But then as we move on, we are definitely going to learn or going to aggregate on this knowledge and learn a lot more. So we are done with the data and data type. Now let's look at another one we have over here, which is the fourth chapter. We are going to look at the Python input function. So far, all that we've done is, and I'm sharing this. So if we take a critical look at the block diagram we have been working with, and let me zoom in a little bit so that everybody can see. You could see that so far we have been exploring instances where we are outputting things. Okay, so for instance, we are using the output unit a lot, and we see a lot of things on our monitor. Okay, where we are seeing things being printed out, and it is almost as if we are dumping everything right onto the CPU for some whatever thing that we want to do. But then there's also the input end of it, where we can actually input data or give our user the opportunity to input data and then maybe do some manipulation before it is outputted for us to see. So with that out of the way, we are going to use the input function. So remember, it is almost as if the print function is helping us print things. So therefore, the input function is going to help us input things. And that's basically that. It doesn't do anything apart from that. So this is what we can do with it. So let's say we have, let's say, and let me use GPA. Let me use, okay, still I can use GPA. So the GPA is, initially was a 3.91, no, 3.99. Maybe, no, let me start with 4.00 because that's what everybody starts with. 4.00. Now, what I did was, okay, we could print this and then say we want to print this GPA. And now when I run this, everything is working. I get to see that 4.0 showing up over here. Now, what if maybe it is a program and you want the user to input his or her GPA? And by doing it this way, as we have it online too, it is quite static, okay? Unless the person goes into the program and get the source code, that GPA is not going to change. It is almost like maybe entering your PIN or your something, okay? There should be some flexibility in terms of what you can input in. So we are going to use the input function to do that. So when I do this, we need to provide a prompt, okay? So this prompt is going to be some kind of a string, and that's what is going to be outputted on the terminal. So normally when you go to ATMs, you see something like this, enter your PIN. So this entire PIN is going to show up, okay? And then what I really want to do, let me just collapse this. When I have it this way, like we have on line 3, it is still going to work. I'm still using the input function and I have the prompt enter your PIN. So when I run this code, clearly we get to see enter your PIN. I can type in my PIN 1111, okay, and press enter. And That's it. Okay, I haven't asked it to do anything. But then I can bring in a variable and say pin is going to be equal to this. So over here, I've declared a pin or a variable pin. And I'm not just putting some static data over here, but then I'm using the input function to help me catch that data, okay, or accept that data through the input function and save it in that variable called pin over here. So now I can do a printing of that pin. So I can do print pin, and I can also print the data type of pin as we've come to learn. So let's see how this one works. So once again, I ran this, and you can see the sequential order. The first piece of logic, remember line 1 is a comment. We don't have anything on line 2. So the first piece of logic is actually what starts from line 3. And on line 3, the logic is use the input function. And the input function, the functionality it gives us, or the utility it gives us, is it will allow us to input things or input data. And once it is able to capture the data, we are going to say that we want to save that data in a variable called pin. Now, as soon as that variable pin accepts that data and it is stored in, on line 4, I want you to print the pin and also print the data type of the pin. Now, something interesting is going to happen, and that's why I brought this up. Let's assume the pin is Ken, okay, which is quite of a weird one, but then no problem. The input, the pin is Ken. When I press enter, now it makes sense because, well, I was expecting Ken to be a string, and then we get to see that, yes, it is of a class str. Now, let me run this once again. If I type 1111, which is my pin, and press enter, on line 4, I'm getting this pin showing up over here. But then I'm still seeing that this is a string. Remember what we saw earlier on. It was possible to do small letter h as 12 and also capital letter H as a string of 12. So now the whole point is this input function will ordinarily or inherently, the way it is such that anything you put in there is a string as far as it is concerned. So even if I come in here and run this enter pin and I type in 4.7, under normal circumstances, we expect this to be a float. But then when I run this, it is still telling me that yes, it is printing 4.7 from line 5. And when it prints the data type, it is still printing it as a string. If I run this once again, and I even type in through this way, it is still seeing it as a string. And that's simply because of the inherent behavior or nature of this input function. Whatever thing you pass through the input function is going to be accepted as a string. And there are means and ways we can get our way around it. And that's what we are going to discuss moving on before we conclude on this chapter. So before we conclude, there's an important concept we call typecasting, okay? And with typecasting, what we want to do is we can actually convert from one data type to another, if it makes sense. Okay, so once again, if it is some PowerPoint presentation I have, if it makes sense, it's actually going to be highlighted and bold. We can convert from one data type to another. So look at this. I think if we have age is equal to 12, and then capital letter H, based on what we know so far, that capital letter H is going to be a string because it is declared in some quotation mark, okay? Now, the point is, through typecasting, I can change this from a string into an int. I remember I said if it makes sense. Well, it makes sense because the numbers in there or the characters I have in there are naturally or could naturally be converted into an integer. All right. So that's what you have as typecasting. So we are changing from one data type to another. So look at this typical example. Now, let's say I have x is equal to this. Okay, so x is equal to this. And now I can say that y, if I do y is equal to x, I have x is equal to a string 12. And now if I say y is equal to x, all that I'm saying is, well, whatever thing you have in x, which is this string, also put it in y. So once again, if I'm to come in here and print y, okay, and run this, I get to see that, yes, I'm seeing 12 over here. If I'm to print the data type of Y, I'm still going to see that, yes, this is a string, because indeed, the original thing, which was actually declared on line 9, was that it is a string based on what we see over here, declared in some quotation mark, saved in the variable called X. And then on line 10, I'm saying that that content should also be saved in Y. And now I'm saying I print Y and stuff like that. So now this is what I want to do. I want to convert, for instance, what I have over here and make sure that this Y is an integer. And it is very simple. Remember when you see, if we have it this way, then X is an int. So then this integer is going to be saved here. And then when I run it, we see this. So now look at what we have over here. So we have this int, which is an int, okay? Int. So if I want to convert, for instance, this string into an int, all that I need to do is I need to pass this value, which is a string 12, into this int. Remember, when we're trying to check the data type, we pass it through the type function. So it's like we are passing things through, and based on the inherent behavior of whatever thing we pass anything through, it gets converted one way or the other. Okay. So this one, even though it is a string, because we are passing it through an int before saving it in Y, now Y now will become an int. So now when I run this, we are getting Y to be an int. Now, clearly the trick is very simple. If I'm to change this into a float, then what it means is, okay, inherently, this is a string. But then because I'm doing a typecasting over here, I'm converting from one data type to the other. And this time around, I'm converting this string, which is 12, into an equivalent of a float. And remember, a float is always going to be a fractional value. So it is going to come out as 12.0. So now, whatever thing we have over here, which is the 12 string, because we are doing a typecasting over here, will now be a 12.0, which will be saved in the variable Y. And now, when we run this, that's exactly what we see over here. So clearly we see a 12.0, and then we see it as a float. And that's simply because we've done a typecasting over here. So back to what we were discussing earlier on, let me just comment this one and come back here, because at least we have some knowledge of what typecasting is all about. Yes, I want to accept this as int, okay, or integers, because like I said, inherently, this input function will accept things and make it a string, no matter how data you present it. So if it is 12, this is still a string, and it is behaving like this 12 as we have over here. Now, if I want to change it into, for instance, how do you call it, an int, what I can do is I can do a typecasting over here. So I put in this. So what it means is, okay, on line 3, a lot of things are happening over here. First of all, I'm going to give the user the opportunity to enter some number. And that is going to be the handiwork of the input function. But then before I even save it in the P variable, I want to change that data type, because, and of course, we are doing this because now we know that everything that the input brings up is going to be a string. However, because of a typecasting technique we are using over here, whatever thing we put in over here will be changed into an int. So now when I pass this, and now I'm typing the same 12. When I press enter now, we get to see that, yes, we are seeing 12, but then this time around, it is an int because we have done some typecasting over here. Good. Now, we need to be very careful when we are doing this typecasting, okay? And because of that, let me just come back to this, because this is the example we are using. Imagine we have something like AMA, and X is AMA. And over here, what I'm trying to say is, okay, pick this AMA and do a typecasting, change AMA into an int and save it in Y. The big question is, does it make sense? That's why I said we can do typecasting if and only if it makes sense. Now, I don't see, if it is very difficult for you to comprehend logically, then we cannot give Python that problem to solve for us. So clearly you can see that it doesn't really make sense converting this AMA as we have over here into an integer, unless maybe you have some coding of these characters over here. So clearly, when you do it this way, we get a problem. So it says there's a value error. And please pay attention to some of these errors we are seeing over here, because later on, we are going to come back to these errors. And these errors are actually going to help us appreciate Python programming very well. Yes, you are not going to be good at it if you don't see errors. But then the moment you're able to fix those errors, that's when you begin to have a better appreciation of computer programming. So these errors are going to help us one way or the other. So we have this value error over here, and it says that invalid literal for int, okay, with base 10. And you see AMA over here. So it was trying to convert whatever thing you have over here in some base 10 numerical value of an integer, and it couldn't see how it should be done. That's basically that. So there's a problem over here, and we cannot continue with it. So yes, but then if it is, for instance, a 90.5 or a 90.4, this by default is some kind of what I call a strange float, okay? The characters in here without the quotation mark makes it a string. However, it makes it a float. However, because of the fact that it is in that quotation mark, it is a string. Now, what we have over here is if I'm to do a simple typecasting of this into a float, then we expect to see a 90.4. However, if I'm to do a typecasting of this into an int, remember, an integer will be a whole number, okay? So it is definitely going to chop off that fractional value. So clearly we see, what do we see? Okay, we get that same issue over here. And the reason we are getting that issue is probably because of this point over here, okay? This point is, Python is trying to figure out, is it a full stop or a point or whatever? It could be anything. That's why we are getting this over here. So like I said, yes, we are at liberty to be doing typecasting, but then we have to be very careful with the things we can do with it. And later on, like I said, we are going to catch these value errors and also try and work our way around it. So definitely we'll find a way whenever we get these problems. So that concludes that chapter. Now let's move on to what we have over here. And this is basically a discussion that we are going to have. And the first thing we are going to look is, yes, we need to understand the inner workings of Python, okay? We need to understand the characteristics of the programming language, because yes, if you are coming from another programming language, you see that the syntax is a little bit different over here. Python is a little bit loose in terms of how you write things, and it is quite dynamic, okay? So there are some programming languages that are static, and Python, we look at it as a dynamic programming language. Now, when we say something is dynamic, it pretty much says it all. Like, things can change, okay? So this is what I mean. Let's say we can have a variable x, and now when I do variable x is equal to 10, clearly based on our understanding of Python, now we know that x is an integer because the value being stored in x is a whole number, okay? Now, I can verify this by printing this and then also printing the data type of x. So when I run this, I get to see that yes, indeed, it is an int. Now, if I come in here and, for instance, do x again is equal to, now I see UG. Remember on line 5, x is an int, and then on line 6, x is UG. Now, what we have over here is we are using the same variable name. Remember, Python is case sensitive, okay? So this was not a capital letter X. This is still a small letter X. So it is the same variable name that we are using over here. Now, when I run this, I get to see that, well, I'm now getting UG, and I'm also getting str over here. So the big question is, what happened to the first x is equal to 10, which we verified that was the 8. So now this is what happened. And this is what I tell students just to understand this. Because of the dynamic nature of Python, okay, the data types and a lot of things you declare and use are determined at runtime. So it is when we are running it, that is when the data type is declared. So remember, at the point of initiation of our program, the data type was an int. It then changed into a string over here. It could have changed x is equal to true. So now it has changed from int to string to now a Boolean, okay? And now when I run this, we get to see that this is a Boolean. And the reason being is the fact that Python is dynamic. Things can change, okay? Now, what I tell students is it's almost like you have, let's say, an image or a file with a name, and you are saving something with the same name. Remember, the name is just like the variable name, okay? And if it is, let's say, a Word document, it is the content in there, which is the data that you are saving under that name. If you have a file with the same name, it will ask you, do you want to overwrite? If you say yes, what it means is now the data in there will change, but then you still have the same name. And that's what we see over here. The same name of that variable runs through, but then the content, the data we are storing in there kept on changing. And that's simply because Python is dynamic. Some programming languages will not accept this. But there's also one thing I need to show, is the fact that on line 5, we started off with 10, we came to UG, and we came to true. So clearly the data itself was changing from 10 to UG to school. However, what was also changing is the data type itself. So indeed, it changed from int to a string to a Boolean. And it could have changed on and on and on, depending on whatever thing you want to do. All right. Now, I'm bringing this up. Normally, you wouldn't see this, okay? But then it is important to know, because sometimes you may declare a variable in a certain way, and as you code along, things may happen. And so just remember, it is dynamic. Make sure that you are consistent with whatever, how do you call it, data type you are working with. Okay. Now, the next one we have over here is a comparison between interpreted and compiled languages. So Python is an interpreted language, okay? And there are some programming languages like C++, Java, and some other ones that we call them compiled languages, okay? Now, these interpreted languages are such that they are interpreted line by line, okay? And this is what I was trying to do the other time, or maybe, yes. So let's say we have something like name is equal to, and of course, we are going to use the input function to accept some kind of name. So I'm going to say enter your name. So this is enter your name. And then I'm saying that print, I'm going to say print name, and I'm going to say print the data type of name. And everything will look good over here. So now when I run this, enter your name. Okay, so I type in Kenneth, I press enter. It is indeed printing Kenneth for me, and also printing the data type of name, which is Kenneth. Now imagine I come back here, okay, after this, and all of a sudden I say print age. Well, I get a prompt over here, okay, and the prompt is kind of giving me a warning that, well, there's a problem. Everything I'm trying to print from line 6 has been declared, okay, especially with name over here. But all of a sudden, I'm trying to print something I haven't declared. There's a variable that I haven't declared, but I still want to see how this one works. Now, when I run this code, it works because everything is being executed line by line. So line 5 works. It says I should input something. So I input something. Okay, this time around, I put in Ken. Now, what happens? Let's take a look at exactly what happens. This is where I put in Ken. So line 5 is working. Then it prints what I have on line 6, which is actually printed over here, which is a Ken. Then it goes on to print what I have on line 7, which is the data type of Ken. But then when it gets to line 8, that's where it catches the problem. And that is where it says that there's a name error. The name age is not defined, and this error makes sense. So now, here's the catch. Because it is an interpreted language, the interpretation is done line by line. But in the case of compiled languages like C, C++, and the likes, it will compile everything, make sure that everything works before it even executes. So that's why you read in some places that, well, When you write code in C++, the code is robust because before it executes, it makes sure that everything is working before it starts putting out whichever data type or whatever thing you want to do. All right. So that's just by way of we trying to understand this. So a lot of the time, yes, we are going to run into some problems because of the inherent behavior of Python. If there's a problem, maybe we have 100 lines of code, and the problem is at line 90. The first 1 to 89 is going to run. And sometimes it can be very painful. Everything is working hard, then the last 2 or the last 3, there's a problem. But in the case, but it is also good in a sense that you also get to trace exactly where your error is coming from. So if everything works up to a certain point, okay, this is where the problem was coming. But sometimes in C++, when you write code and you are using a very old compiler and things are not working properly, it becomes very difficult even tracing where the error is emanating from. Now, the last point we have over here is trying to compare between high-level languages and low-level languages. And once again, Python is a high-level language. So let me quickly explain what this high-level language is all about. Now, look at, for instance, the code we have over here. Okay, let me get rid of this. Earlier on, I said this CPU, okay, as we have over here, only understands zeros and ones. That's how it is built, okay? It is a digital system that only understands or that only accepts electrical signals that we are going to pass. However, whatever logic we are given as CPU, as clearly as we can see over here, it is not anything closer to a 0 and 1. However, this is something closer to some human readable language. So for instance, I see, it kind of makes sense to me what an input is. I see something like print. I'm declaring a variable called name. I see this is almost like an English statement I have over here. Okay. Anybody who probably hasn't done Python programming before will look at this and wouldn't even probably look at it as let's say some code. The person will look like, oh, you've written some statements over there. And that's simply because of the fact that Python is a high-level language. So this is what I tell students. Once again, Python gives us some vocabulary, which is human readable, which is human understandable. And it will rather convert, for instance, the inputs, the print, and all the other vocabularies you are going to learn into some zeros and ones that the CPU will understand. Who knows? Maybe this input is what I have written over here. I don't think so, but then let's assume that's the case. It is easier for me to remember a high-level version of this input than to put this one over here. And that's basically what Python gives us. So we are going to write this high-level language syntax and everything is going to be converted for us. All right. I believe that's going to be the end of this particular section or this chapter. Now let's move on to the next one, because based on what we know so far, especially with the dynamic and static programming languages, a lot of things are going to become clear. And we are moving on to the next chapter where we are going to look at concatenation. At this point, let me find out if there are any questions. Are there any questions? Okay, so I'll assume the silence means no. So let me proceed. Once again, the videos are being recorded, so I'll start sharing them so that you have access to them to revise. So we have a very big word over here, which is concatenation. So like I said, it's a very big word, okay? If you haven't done programming before and you hear this word, you'll probably be scared that, hey, in programming, there's something called concatenation. What does it mean? Now, it is a simple thing. And it simply means you are joining 2 or more string values together. Concatenation simply means joining 2 or more string values together. And we know what a string is. Anything we declare either in a single or a double quotation mark. So the example I always use is, I have something called first name, okay? And I'm going to say Kwame. And I'm going to have last name as Nkrumah. So I have Kwame Nkrumah over here. But then I want to concatenate, or better still, I want to join these strange values. They are all strange, okay? I want to join them into something called full name. So what I can do is I can simply do first name plus, and I'll say last name. When I do first name plus last name, because they are strange values, I'm not adding them. I'm just doing a concatenation. All right. So what happens over here is if I'm to print out full name this way and run this, I'm getting exactly what I ordered for, okay? I'm getting Kwame Nkrumah concatenated or Kwame Nkrumah joined together. Those two strange values have been joined together. But then this probably may not be what we want, okay? So maybe you want Kwame and a space and Nkrumah, or better still, a space between or in between Kwame and Nkrumah. And I would like to find out, what do you think we can do, okay, to bring a space in between Kwame and Nkrumah? What can we do to bring a space in between Kwame and then Nkrumah?
Hello.
Yes, please. I'm listening.
I think we can also probably put the space as a string or something in the write-up.
All right. That's a viable option, okay? So some students tell me that, oh, well, they can bring a space in front of Kwame. So this one will work clearly. We see that there's a space between this and this. Or they'll bring a space before Nkrumah. And then this one is also working, okay? Or better still, like I said, we are joining two or more strings. Currently, as it stands, it is just two strings. So we can actually bring up another empty string over here and also join them. So now on full name or on line 5, we have the first string, which is Kwame from first name. And then we have concatenated or we have joined it with an empty string or more or less a space and also done another concatenation over here. So now when I run this, we get the same output, Kwame Nkrumah with that space, and everything is pretty much better than we expected earlier. So this one solved the problem. Now there's even an elegant way of going about it, and that's going to be because we are going to use formatted strings, okay? And moving on, we are going to use formatted strings a lot. So now let me just comment this one out. And now let me just put in something like, I want to have a statement, okay? So the statement, sorry. And the statement is, I can say first name, okay, plus space. So I'm getting Kwame, then Nkrumah, which is going to be the last name, okay, plus Kwame Nkrumah was, let me just also create another variable over here. Let me clear this. So I'm going to say position. I'm going to say president. And I'm going to say hometown. We are gradually learning some history over here. So I'm going to say Nkrofo, something like this. All right. So I want to have a statement like Kwame Nkrumah is the first president of Ghana. And let me have country. Kwame Nkrumah is the first president of Ghana and he comes from Nkrofo, something like that. When I decide to use this way of concatenation, where I do, okay, I have Kwame plus space, last name Nkrumah plus, so Kwame Nkrumah is the first, then the position is over there. So the position, I'm bringing plus position. And you can see it is getting a little bit messy over here. Well, let me just not bore you so much with this whole statement because if I'm to print this, yes, we are getting things working properly, but clearly you see that there could be an easier way of handling this, okay? And that's what we use these formatted strings for. So let me just show you this. Yes, it is a string. So we bring in this, and because it is a formatted string, we do a prefix of F over here. Now this F could be capital F or small f. All right. So when I do this, now what I can do is I can type in anything over here, okay? Now anything over here is still going to be seen as a string, as we have it over here, even though we have this being prefixed by an F. However, the beauty about this formatted string technique is I can bring in placeholders, okay? And these placeholders, I'm going to use this curly brackets. So when I use this curly bracket, I can now fix in a variable. So I can say first name, space, another placeholder, last name.
All new iPhone users do these 3 mistakes. Number 1 is,
and I then don't need to be bringing these class and stuff like that. So I can say Kwame Nkrumah was the first, then bring in another placeholder, position, okay? Was the first president in, then I'll bring in another placeholder, country. He hails from, then bring in another placeholder, then I can bring in the hometown variable over here. So it becomes
intelligent men, Stacy.
Because they overthink a lot.
Give your strength to win.
please, oh, I'm getting some feedback from somebody. Okay. So we get to see that we have the statements over here, and this one then becomes very easy to read, okay? Because we get to see first name, last name. So clearly Kwame Nkrumah was the first position as president in Ghana, because country is Ghana. He hails from Nkrofo. And this one is cutting down on a lot of the pluses, everything that we were trying to do over here. So it pretty much makes our work a little bit easier for us by just using formatted string. And all that we are using is we are prefixing this with an F. If I don't bring this, clearly whatever thing we see over here is also going to be seen as some kind of a string. Everything is in a string. So that's what you see. First name, like whatever thing. We have to make sure that we prefix this with an F. Please, there's no space between this F and whatever thing we have over here. It needs to be attached. Or better, so you could have used the capital F, which it is still going to see it as a formatted string. So that's basically everything about concatenation. The key point is we are joining 2 or more string values together. All right, so that brings us to the end of this particular chapter. Now let's go to strings. Now that we know a little bit about strings, we know that yes, whenever we have anything declared in a single or double quotation mark, it is a string. All right, but then we want to verify and actually see exactly when we are under obligation, or when we really have to use a single quotation mark, and when we also we are also under obligation to use the double quotation mark. So let me give you a typical example. Yes, I have the variable, let's say, let me use a very simple one. So let's say course. And the course is Python programming. So now if I'm to do a printing of course, and run this, we get to see Python programming over here. So far, this is what you've been seeing. Now, what I want to see is, and this is exactly how I want to see it, okay? I want to see Python programming. Now, when I have it this way, all I want to see is I want to see Python programming in a single quotation mark. Currently, as it stands, it is not in any quotation mark. I want to see Python programming being printed out in a single quotation mark. So now, if I want to see it in a single quotation mark, then we'll then be under obligation. But then the obligation is not going to be this way. If I put it in a double quotation mark, it is still going to show us as Python as if there was no quotation mark around it. So if I want to see it in a single quotation mark, then I have to use a double quotation mark at the outer layer, and then In the inner layer, I bring in the single quotation mark. Basically, what this means is this first outer quotation mark is going to make it a string. And whatever that exists in between is what is going to be printed out for us. So now when I save it this way and run this, we get this Python programming in a single quotation mark. So now, based on that, we can also infer that if I want to see this in a double quotation mark, the same thing, Python programming. If I want to see Python programming in a double quotation mark as I have it this way, then what that means is, okay, I just have to do the reverse of this. I just have to make sure that the outer quotation mark is a single. That makes it a string. Then whatever thing I have in here is going to be wrapped in a double quotation mark. So when I have it this way and I run this, you get Python programming showing up in a double quotation mark. There are some instances, especially those of you who have been doing a web using Django or Flask in Python, you get to see some of these things in and around whenever we are passing in some URLs and some links and stuff like that. All right. And depending on what we do, maybe we'll get to experience some of that piece of programming very soon. So that's basically that, and that's pretty much it. Okay, we don't have to worry so much about this. Now let's move on to what we have over here, and that's with indexing. So please, this one, we are going to definitely come back to indexing because the principles we are going to learn over here, we are going to apply them in some other variables. Okay, let me just put it that way. So let me just have something like a variable called school. And I'm going to say University of Ghana. So that's the school. Now remember, this is a collection of characters, okay? And they've all been put together inside of this quotation mark, regardless of whether double or single, into a string. Now, each and every character over here has a position inside of this string. Each and every character. So for instance, the first character we see over here, which I've actually put the cursor under, is this capital U character. I'm saying capital U because Python is case sensitive, so I have to be very pragmatic with this. So this capital U character is the first position. Then N or small letter N is the second position. Then we move on and on. So we get to the last position, which is this small letter A as we have it over here. Good. Now, the key point we need to understand is whenever Python is counting, it starts counting from 0. So the indexing starts from 0. So what it means is, what Python sees is the character U is at index position 0. Then the character N will be at index position 1. The character I will be at index position 2. The character V will be 3. And we can go on and on and on and on till the last character as we have over here as A. Don't worry, we are actually going to see that index position of A very soon. So now, if I'm to do a printing of school, which is a variable saving this data as we have it over here, if I run this, yes, we get to University of Ghana because that's exactly what we have over there. Now, the key point is if I'm to bring a square bracket this way and leave it blank, clearly I get a warning that there's a problem or there could be a potential problem. Now, if I overlook this warning and still try to run, it tells me that, well, there's a syntax error, invalid syntax. Perhaps I forgot to bring a comma, or I forgot a comma, which is even making me more confused, okay? There's no comma over here. But then look at this. If I pass in an index position of 0, all that I'm trying to say is, well, I want you to print school, but I want you to only target what character you have at that index position 0. So over here, we know that the index position 0 holds the value capital letter U. So now when I run this, we only get U showing up over here because of what we are doing over here. We are specifically selecting out of that entire piece of string. In that same way, if I do index position 1, then that's going to be the small letter n. So when I run this, I get small letter n over here. Please pay attention very well because I have a short exercise for you before we finish this section. If I do index position 2, then that's going to be I. Index position 3, that's going to be V. So I can go on and on. So now let's do the counting over here. So this is U is 0, then I have 1, 2, 3, 4, 5, 6, 7, 8, 9. Y is 9. Then the white space I have over here is 10. It is also a character. 11, 12, 13. That's another white space. 14, 15, 16, 17, 18. So the A I have over here, I believe is 18. So now let me check. I do 18 over here, and I run this, and I get this A. So now, this presupposes that when I do 17, I should get this N. So now let me do this 17, because it could have been either this or that. I just want to be sure. Okay, I'm just trying to play the devil's advocate over here. I get, okay, so if 17 is giving me the N, then indeed 18 is actually going to give me the A. Now, what about if I do 180? Clearly, the last character we saw over here was, how do you call it? Index position 18. So definitely 180 probably is going to give us some error. And indeed, that's what is going to happen. So when I run this, the error also makes sense over here. It says there's an index error because based on the index positions of the various individual characters we have over here, we have exceeded what our range is. So it says that the strange index is out of range. So clearly the index we're passing over here is out of range. However, when I do an 18 over here, we get this. Now, one of the few things you would appreciate is that, okay, fine. The last position based on this string we have over here, it is index position 18. However, Python supports negative indexing. So if I simply just want to get the last character, imagine if this was University of Ghana, Legon, P.O. Box, I don't know, 25, Accra Central. You can imagine, I still have to be counting up to this. I don't have that time. So the point I'm trying to make is the moment I do a -1, then it is going to pick up the last character I have over here. So that's what I have over here. If I'm to do a -1, now it's going to be L. So now when I run this, I get L over here. So, okay, everything is working. What about a -2? A -2 is now going to count from behind. So a -2 is going to be this, A in the central. And now we get this. A -3 is going to be that R. So a -3 is going to be that R as we have it over here. All right. Now let's just get back to what we're using. So now when I do a -1, the -1 is going to be the A. And a -2 is going to be the N. A -3 is going to be the whatever you have over here. Now, what about a -300? Let me find out, trying to use your own intuition. What do you think a -300 based on what we have learned and based on what we see? What do you think we are going to get? Anybody can volunteer and give us an answer.
So I think it will tell us that it's out of range.
Exactly. Thank you very much, my brother. So definitely, I mean, using our own intuition, when it was a very large positive number, which was very glaring and obvious, it was out of range. Now, clearly, if we are to use that same principle, we are going to count from behind. And probably by the time we get here, that one will be the 19 or -19, and then definitely out of range. All right. So definitely when I run this, of course, we get an index error, and it tells me that this is out of range. Now, remember, when I do a -19, And negative 19 is going to work over here, okay? So when I run this, I get this capital U. And the reason being, well, when it is counting from behind, it starts with -1. We don't have -0. Is that okay? 0 is 0, whether positive or negative. Good. So when it is counting from behind, it starts with -1, but then when it is counting from the beginning, it starts with a 0. All right. So Python supports negative indexing. So that's just one way of looking at this. Now, the other thing we want to actually see is, okay, what if I just don't want to print just a single character? And like I said, later on when we are dealing with matrices, these techniques are going to come in handy. Okay. So just pay attention over here. When we get there, we are going to transfer that knowledge and understand some few things. Now, remember initially, if I do this, we get a problem because clearly it doesn't understand what we want to do. The moment I bring in an index position, now it understands. Now, however, when I bring in a column this way, it seems to be okay. And indeed, when I run this, everything is working, okay? Now, it is important or instructive to note that, well, what I have over here, and I'm just opening it up so that we see things very clear, okay? We are not going to have any error. Everything is going to work. Now, when we have something like this, what we basically would want to do, or what we typically would want to do is, okay, at the beginning, we can pass in something. We can pass in a number. And also at the end of this column, we can pass in a number. Whatever thing we pass in over here is going to be our starting index position. And whatever thing we pass over here is going to be our ending index position. So now look at this. Let's say I want to print, let's say, based on what we have over here. So let me just count. We have 4, R is 5, S is 6, then 7, 8, 9. Good. So yes, the entire string is University of Ghana. But let's say I just want to print out university out of University of Ghana from this variable school. I can start with an index position of 0. And please, let me just put it out over here. The starting index and please, if you have, or if you are taking notes, please write this. The starting index is inclusive and the ending index is exclusive. Simple and short. The starting index is included and the ending index is excluded. It is not part. The starting index, it is part. So when I do this and passing a 0 over here, all that I'm trying to say is, well, start printing from 0 because the starting index is inclusive. Now, if I'm to put in a 9 over here, at least based on what we see, 9 is going to be the ending index. And because it is exclusive, it is going to be chopped off. So over here, we are just going to see university. Okay. So that's what I have over here. So now when I run this, indeed, that's what we see, university. So if we want to have university, then we have to rather go to the index position 10. And in this case, the index position 10 is going to be this empty string over here. But then because it is exclusive, we don't even really matter, or it doesn't really matter. So we get this university showing up over here. Good. Now, what about if we want to print, for instance, maybe Ghana? Now, this is 10, O is 11, F is 12, then this is 13. Now, this G will be 14. So now I want to start printing from index position 14. If index position 14 is the case, then the big question is, where do I want to end? I simply just have to leave it blank. When I leave it blank, that means everything starting from this index position, which is G, 14, which is inclusive, start printing from G and forget about the index position, print anything that you see alongside. So now when I run this, we get Ghana over here. Assuming I bring in Legon over here, because the index position is left blank over here, it is going to print Ghana, Legon, because when I leave it blank, I mean print everything. Okay. So when I have it this way, it prints everything, Ghana, Legon. All right. Now, the big question is, I just want to print, now I want to print Legon. So there's the exercise I have for you, okay? And I'm even going to make your work very simple. So I want to print Legon, but then I want the index position to be negative. Let me repeat myself. I want to print just Legon, but I want the starting index position to be negative. Like I said, that's even going to make the work very easy for you. So what do you think is going to be the output, or how you are going to write this, how you are going to slice your things up? I want the starting index position to be negative. If anybody is ready with an answer, maybe he or she can share with us. I just want to print Legon, but I want the starting index position to be negative. Do we understand the question? Okay, somebody has an answer over here. Wow. So let me copy what you have over here and put it inside the code so that we actually test the answer. So now the big question we need to ask is, okay, we are starting from, this is our starting index position, which is -1. The question is, which character is -1? -1 is n. But then look at this. This is -1, -2, that is O, -3 is G, -4, -5. Okay, so now if I'm to do a -5 over here and leave this blank, look at this. If I'm to put a -5 over here, that means I'm starting from L, which is inclusive, and I'm leaving the ending blank because I want to print everything up over here. That is where I'm actually going to get my Legon showing up over here. So like I said, the negative starting index position was even making the work very easy, but I think maybe overthinking. And don't worry, we'll try our hands on different examples, especially when we get to the matrices, because for some matrices, we need to be slicing and, for instance, picking up on the row or just on a particular column or maybe some particular position. Okay, we are going to come back to this. But then the key takeaway is the starting index position is inclusive and the ending index position is exclusive. If we are interested in printing everything thereafter, then all that we need is our starting index position and we leave this blank. So now if I'm to leave this blank and also put up a 10 over here, okay, remember our y is 9 and this 10, because it is blank, I'm saying that our ending index position is 10. So what I have over here, what it means is, okay, because I've left this blank, then anything that precedes this ending index position is going to be printed. So over here, yes, I'm going to get University of Ghana showing up this way. Or sorry, university showing up this way. Better still, if I had brought in a 0 over here, because the starting index position is inclusive, it is still not going to worry me. So I still get same results. Don't worry, when you are doing this for the first time, it can look a little bit confusing. But the most important thing is, you need to ask yourself, what do you want to print? Or what you want to get out of the slides you want to get out of that entire string. If you want to get something, then ask yourself, okay, where is it starting? Where is it ending? If it is starting from the beginning, I don't even have to worry about this. I just have to concentrate where I want to end. And because the ending index position is exclusive, I always have to make sure that there's an extra allowance of 1. Okay. Let's just move on. I know I've been doing this for about 3 or 4 years teaching students. So normally when it gets to this part, I get the facial expressions from the faces of students. Unfortunately, this is an online, but I get the feeling some people are smiling in a certain way. But don't worry, it will come good. Now let's look at another example over here where we are going to use the len function. Okay. Now this len function is going to basically calculate the total number of characters we have in a particular string and give it out to us. So let's say I have course, and let's say it is Python over here. So I don't want to waste time calculating. So how many characters do I have? I know I have 1, 2, 3, 4, 5, 6 characters, okay, in Python. What I want to do is I want to use the len function to do that for me. So when I do len, and I'll pass in, passing course, which is a variable. Now look at what I'm going to do over here. Whenever I hover around a particular function, it tells me what it is, okay? So it tells me that, okay, well, this is a function, okay? And it gives me some kind of description. Now, what you see over here, and this is something we are going to see a lot, okay? This is what you need to do to understand the inner workings of programming. Later on, we are going to see how we write our own functions and how some of these things are actually architected. Now, what you see over here is, this is always going to tell you the kind of output this function is going to give. So it is telling you that this function is going to return an integer. And over here it says that it returns the number of items in a container. So once again, everything is coming back into full circle. The definition we gave a variable was, it is a container that we are storing some data in there. And we are saying that, okay, this len function is telling, or is going to tell us the number of items we have in a container. The items we have in this particular one are the individual characters. So now see what's going to happen. When I run this, well, it was telling me it is going to return the number of, so I was expecting to see some 6 over here, but then I'm not seeing anything. Who can tell us what we need to do and why we are not seeing 6 being shown in the terminal? Anybody can speak. Okay,
I think
Derek.
we can assign it to a variable.
We can assign it to a variable. Okay, then, so let's say the variable.
Then later print it.
Okay, so we can do x is equal to this, and then later print x, which is a very systematic way of handling this. Is that okay? So over here, we are applying the len function, this variable, the container. It will calculate or return the number of items it has in there, put it in a variable called x, and then we print it out. And that's exactly what we see as 6 over here. Now, alternatively, we could have gone straight ahead and do the printing, okay? So over here, we can wrap things up in a print function this way. Remember, initially, if, for instance, I wanted to check the data type, we do a type, and now when I run this, we get str, which is a string. That's exactly what you see. If I want to use the len, we wrap everything up in a len function, and now when I run this, we get 6 over here. Now, the point I want to prove over here is the inner workings of what actually print gives us. Because without print, when I run this, indeed, it has calculated and seen that, okay, it is 6 characters in here. But then we haven't given it any further instruction to print it out for us. Remember what print does? It is going to print whatever thing we put inside of it. Currently, as it stands on line 15, we are not calling print, and print is nowhere near our code. So if we want to see things in the terminal, then we have to wrap everything up in a print function this way, so that, okay, it checks for the variable course. And because we are passing this in the len function, and for which reason the len function returns the number of items in the container, it is now going to print everything out so that it becomes very visible for us to see. And that's exactly what we see over here. All right. So that's just by way of information. At least we are learning a lot about these strings. Now let's come to strange methods. And probably we are going to conclude over here, and hopefully when we meet on Friday, we are going to expand or extend this conversation and end and move to the other. Now, I tell this story all the time. I don't know the schools some of you went, but then I don't want to believe we all did some basic school, and I asked this question in one of my classes, and some students were giving me some interesting answers. So I go by this. So when I was in school, we learned some few things. We learned capital A, small a. Those of you who typically went to Saito schools, you learn A and Neba. I think it's about those who went to the DV schools who are doing capital A, small. And I asked somebody, or I asked students, whoever went to school and was doing capital 1, small 1, capital 2, small 2, capital 3, small 3. And I was shocked. And students will always surprise you. I have some students insisting. When I asked them which school they attended, they mentioned the school. I was like, hey, are you sure? They said, you didn't go to school with us, so that's what we saw. All right. But having that at the back of our minds, let's analyze this objectively, okay? Is that we can do capital A, small a, but we cannot do capital 1, small 1. So now the point I want to make is, well, then there are some things we can do on strings, because the capital A, small a, we are looking at them as strings. Is that okay? There are some things we can do on a string, but then we cannot do them on numbers. And also there are some things we can do on numbers, we cannot do on strings. Later on, we're also going to realize that, well, there are also things we can do on floats, we cannot do on integers. So for instance, I can round a number to the nearest whole number, to 2 decimal places, to 3 decimal places. I cannot do that on a string. I cannot have AMA 0.5 or AMA point AC. It is not going to work. I hope you understand the whole concept. And that's the whole storyline about string methods. So now the big question is, what is this method? A method, it is also a function. And we are being technical over here a little bit. Later on, when we start with object-oriented programming, we are going to learn about classes and objects and methods and all that, okay? But then, so far, we've come to an appreciation that, well, these functions gives us some utility. Therefore, when I'm saying that functions are methods, or methods are also functions, what it means is, okay, they are functions. However, the utility it gives us, it is only applicable to a particular subset or group of things. So for instance, when I say string methods, all I'm saying that these are functions that are only applicable to strings, just like capital A, small a. It is only applicable to strings. I cannot go and use capital A, small a kind of logic on numbers. Unfortunately, some students were arguing with me that they did that in school, but that's just by the way. So over here, we are going to learn some few string methods. Later, we are going to write our own classes, we are going to write our own methods, and we are going to see that it is the same thing, but it depends on how it is structured. So look at this. Let's say I have school, and this time around, I'm going to put everything in lowercase. So University of Ghana, everything is in lowercase. I can pick this and apply a string method and change this into all capital letters or all whatever thing that I want to do, okay? So look at this that I'm going to do. When I do school, and in order to apply a method, later on when we deal with object-oriented programming, we are going to, like everything is going to come in full circle, you are going to appreciate this very well. When I do school, which is a variable, and I want to apply a method on it, or I want to apply some kind of functionality on it, all that I need to do is I need to do a dot. And this dot, this is how I look at it. It's almost as if I want to go into it, okay? This is the dot operator. So now the big question is, when I go into school, because it is a string, I have a number of things that I can do with it. So let's start off with this upper method. And remember, I said these methods are functions. The way we work with functions is the moment I bring in a function, I need to bring in a parenthesis. So over here, you can see that clearly it's telling us that, well, this one will return a copy of the string converted in uppercase. So it is giving me a copy. So it will copy the string and give it to me in uppercase. So now, if I'm to print out school and run this, I'm getting this. Sorry, let me just wrap everything up over here. If I'm to wrap everything up in this, okay, I'm now saying school.upper. Now, when I run this, I'm getting a copy of this all in uppercase. Now, one of the things I've found interesting to also share with students is what we have over here. Let me just show you this quickly. And this is just for you to appreciate some of the things we see over here. So now, what I did was University of Ghana. Let me make sure this is small letter U. So this is what I had. And just look at it as, okay, those who wrote this kind of software, which is the Microsoft Word, all that they did in terms of we trying to know the functionality or we using this was, okay, they wrote some logic such that when I click this and now click on this uppercase, it is going to now invoke or it is going to call that upper method on this whatever thing I've selected out over here. So whenever I do this, it is now going to change it into uppercase for me. That is basically what is happening over here. So whatever text you have inside of that text area that you have, and when you select that uppercase option, as you saw me do, it is going to, behind the scene, this is like the code behind the scene. It is going to invoke this upper method on whatever thing you selected, and it is going to print out, or it's going to show you University of Ghana, just as we have over here. And you can see that, yes, with this example, we have other ones. So we have the sentence case, as you can see over here. We have the other ones, the lowercase, make sure everything is lowercase. We have the capitalize each word, that's what you see over here. And there are different examples. And those examples are also here as well. So I just have 2 minutes. Let me just wrap up over here. And maybe for the, well, it's just level 1 minute. For the purpose of not going deep into this, because there are some few things we just need to cover. These are some basic string methods. We are going to look at them, and hopefully on Friday we can complete a number of the things we have over here and finish up. Please, are there any questions that or any clarifications that I need to make on some of the things we've said? Any questions? Okay, if there are no questions, this is what I want you to try your hands on. Okay, so let me just show this. And this time around, using the slicing technique, okay, that we just learned. Let me just use something like this. So this is going to be a variable called course, and we are having Google machine learning training program. So this entire piece of string, I would want you to do the slicing of it, okay? The slicing of it, and I want to have Google. Then I also want to have machine learning. Then I want to have another string constituting the words training program. Then I also want to have just program. And of course, I want you to be innovative about this, okay? In a sense that at least for 2 of them, okay, at least for 2 of them, try and use negative index. I want us to have different answers. Okay, so at least these are the 4 for at least 2 of them. So maybe you can decide to, for the printing of the Google, we want to use negative indexing, and maybe for the printing of program, we want to use negative indexing. Then these ones you use positive indexing. Or somebody can decide to say that, okay, I want to use negative indexing for this and also negative indexing for this. And this is going to be the positive ones, or the ones I'm going to use positive indexing. So kindly do this and also try your hands on different things. And I think it will come good. The most important thing is once you have that print, or let's say once you have this way, and you have this square brackets, you bring in your column. The first question you need to ask yourself is, okay, what is your index, starting index position? And that is inclusive. Your ending is exclusive. So if it is Google, where are you starting? You are starting at J. Okay, J is inclusive. So you can start from 0. Then what do you want to end? You want to end at this. So you do this. Nothing like that. and I think you do. So please, let's get this simple exercise out of the way, and I believe when we meet on Friday, we can make progress. In the absence of any questions, I think I'm done today. Dr. Mills. Okay. Akofa, is your hand up or you are clapping? Okay. Sir, Dr. Mills, please, I'm done. Okay, so let me check from Dr. Mills' office. Maybe he just stepped out for his closing remarks. I'll just be back. Just a minute.
Yeah, okay. Hello, yes. Good evening to all of us now once again. So we are done with the session for today regarding the programming, the Python programming, how far we have gone in terms of data type, then the integer type, Boolean, all those things. So Friday will be an in-service session, in-person session, and then the video will be shared to all of us on the platform so that those who are not able to join, they can go through it. And if you have any problems, then we can discuss Friday. The first thing is Friday before we start, you let us know so that we can do some quick review of what has been done. And if you have any issues, we attend to that before we start. So on that note, if there's no further question, does anybody have any question? Does anybody have any questions so far? Okay, so please go ahead. Who is that? Is it Andersimon? Okay, Sheriff.
Yes, sir. Please, Mr. Bruni, can you please go over the range again? Just a
Okay,
simple.
so the time is, we will discuss that on Friday.
Oh, okay.
So if we have, so the question is on the range. Okay, so we'll take note of that. Any
Yeah.
other question? Any other question? Okay, so Friday, God willing, Friday we'll all meet again. Do a quick, if you have your question, you let us know, then we can prepare. Then Friday, we deal with that within 20 minutes, and then we'll continue with the session for the day. We wish everybody a good week. Bye-bye.
0 to